Already we got some let's make meeting in New York. When would be the best for you?
Yeah, I will phone you later or during the week, but probably after September could be good. And because now it's summer is arriving and everything is booked. But I would like to visit you and also your club in New York because I will
Yes.
be around for a trip. You will be around in France, South France. Where are you now, by the way?
I am in New York. I'm in
Ah,
Southampton, in
mhm,
Long Island, next to New York. And
mhm.
then I'm gonna go in September to Frankfurt
Ah,
for surgery anesthesia meeting and then for vaccines meeting.
yeah.
Then I have another conference of in Malaysia,
Mhm.
Spain, Portugal, all, and then it's possible on the 10th, 11, 12 of October, we can do something.
Yeah, now he's recording. Let's speak later, Dana.
And maybe if I may very quickly, I think in 3 minutes we start. So just can you hear me?
Yes,
Yes, yes.
Yeah, yeah. Just because I didn't have any briefing for this before. So you're saying you have a 35 minute session, Francesco, and then at 10:35 CT my session starts. My schedule is also I was told 20 minutes for a presentation and maybe 10 minutes for questions. So total of 30. Is that what you can confirm?
Yeah, there is. I'm just opening because there is a program Kiram sent, I think, a couple of years ago. If you look the what, are you able to look the WhatsApp now? Our
No, I didn't. I wasn't connected to WhatsApp. I didn't get
so
anything.
let me try to share my video just a little bit.
Yeah, but I think it starts
Yeah,
in if you can just confirm the schedule. So
yeah. I'm just looking. No, I am not able to move the. Okay, here it is. This is the schedule. Are you able to see it?
no,
Hello? Ah, no,
yeah,
because I
no,
need to. No, because I need to
just
see it. I
Yeah,
need to.
Marcel, we can hear you.
Yeah, yeah,
I can
but
see the screen, but I don't see the schedule. So okay, but anyhow, so in 2 minutes, I think the audience will come, and there's only these two speeches, yours and mine, or
no, no. There is. If you don't see this, the screen is a problem because I need to share my screen.
yes, we
I
see
see
your
the
screen.
screen, but I
Ah, okay,
don't see
okay,
this.
okay. So yeah, there is a keynote. We have a plenary forum speech, and then there is a keynote forum after this. So it's
Okay,
it's it's a it's a long day. It's a long day, Michael. So and
Yeah, Professor Dana, shall I start with the introduction?
Uh, uh, yes,
Yeah. A very cheerful morning to all the honorable guests, speakers, delegates, students, and all participants present here. It's my honor and a great privilege in welcoming you to International Webinar on Artificial Intelligence, Big Data, and Machine Learning. I am Kiran. It's my pleasure to be a moderator for this conference today. On behalf of organizing committee, first of all, I would like to thank you all for finding time from your busy schedule to be here today. Today marks a major activity in the brief existence of Artificial Intelligence, Big Data, and Machine Learning webinar, a moment where we are interacting, sharing experiences, and reflecting on various areas. In this occasion, we shall have outstanding presentations from our prominent presenters, whom I believe shall enrich our insights and knowledge. Artificial Intelligence, Big Data, and Machine Learning 2025 program will focus on currently employed technologies, disruptive innovations, and the application of recent progress and evidence-based data. The webinar experience is for everyone involved in the delivery, development of artificial intelligence, big data, and machine learning, as well as those who are actively involved in participating in educational programs. The conference particularly welcomes contributions from faculty, researchers, industrialists, and students, etc. We highly appreciate each and everyone for the participation and also the chair, namely Professor Dana from European Medical Association, United States. We hope you enjoy the conference and your participation will contribute to your professional development and relationships.
Now we declare the conference open. Over the years, we had several meetings. This is, I think, our third or fourth. And we had a great pleasure and privilege to listen to Professor Yantori Francesco. Please, Professor, if you can start the lecture.
Yeah, I will start
Yes.
with the introduction of the Professor Francisco.
Okay, can I
Professor,
start?
yes,
Okay,
I
no,
will
sorry.
introduce you.
Go ahead.
It's my distinct pleasure to introduce our plenary speaker, Professor Francisco Ayalori. Professor Francisco is a visionary and facilitator who has been at the forefront of driving digital transformation in organizations since 1990s. Leveraging extensive technological expertise with nearly 30 years of global experience in sales, strategic planning, and business development, spanning various industries including major players in the global information technology, finance, media, and mobile operator sectors. Constantly driven by a passion for learning and sharing knowledge, always willing to adopt and educate. A skilled organizer and team player, renowned for identifying and capitalizing on emerging business opportunities. Possesses in-depth knowledge of potential new products and services, both from a business and technological perspective. Excels as an empathetic storyteller, captivating audiences in keynote speeches and academic institutions, instilling a hunger for knowledge that resonates with the essence of our world and its continual improvement. A visionary who constantly seeks metaphors and paradigms, exploring the depths of our existence. He is passionate about the practical applications of science in our everyday lives, with a keen interest in music, arts, painting, and various forms of human expression. He offers valuable advisory services to investors and multinational companies venturing into a new geographic markets, including Europe, USA, and Africa. He actively collaborates with the United States in efforts to uplift developing countries. Additionally, he holds roles as an independent journalist, sought after keynote speaker at international events, columnist, and esteemed university lecturer. Please join me in welcoming our plenary speaker, Professor Francisco Ayalori.
Okay, thank you, Kiran, for the introduction. I'm just set up my screen, try to share, and where it is. Let me start the presentation here. Okay, I hope I need to remove. Okay, I hope you see something, hopefully. Okay. Okay, good morning. Before I begin, I want to extend also my gratitude to each of you to be here today. Thank you for taking time out for your busy Sunday and join me in this presentation. We embark in this journey a presentation that I will hope it will be insightful and rewarding for us all. And I will speak about the evolution of human and interact human evolution with technology and what this means for us a human and also for technology, which is could be the benefit that I hope for technology. So we start with the cavern, with the caveman, and to arrive to chatbot. It's a long path, but we will try to see it in 20 minutes, half an hour maximum. So we will start. So the first thing I would like to discuss with you is a Bevarina fish trap. Bevarina is a technology for peace made by Aborigines in Australian. They had a problem that every people at that time has. There was 40,000 years ago, and they need to eat. They need to look for food, and the very easy food to take was the fish. There was a river there, and let me see if you can see also my mouse. There is a river that's floating around, and the idea was not to take all the fish or every fish, but only the fish that it's enough big, and at the end of their production. They chilled production, by the way, so they can reproduce themselves. So the idea is that they make a sort of trap there. All the trap was a different height. That means that the big fish can remain in this kind of gulf, let me say, made by stones, and the other one flow away. So the idea is that you can capture the fish, but only the fish that is useful for food enough, and also cannot be very, very young, because the young people that are smaller, they flow away and go up. So this Bevarina, it's an idea many years ago in Australia, in East Australia, to make this in New South Wales, close to Queensland border. Was created by the indigenous people, but the idea is to have something sustainable, and the food need to be gathered for cooperation between also nature. This is the photo. If you are in that area, that is what did remain about the Bevarina fish trap. You can see also the fish that coming from the right to the left, and you can see the trap that is different type. Same thing for fish, same thing for trap, is something around Europe, precisely in Italy, and more precisely to Apulia. The name of this trap is Trabucco or Trabucchi. It's a traditional wooden fishing platform that you can see along the Adriatic Sea. And the idea was by Phoenician, made from Middle East, that arrived in the coast of Italy, from the east coast of Italy. And they, like the Aborigine, understood something to cut the fish. And there is a net here that you can put down on the sea, but not close to the beach, close to the start of the land, but very, very away from the land, where the sea is deeper, and also the fish is big, because small fish go in a high deep sea. And you can see here in this place, there is a lot of these things of Trabucco, but the idea is that don't take the small fish, but take also only big fish in a specific places. This is also put in a specific place of the herd, where the flow of the sea go from southeast to northwest. And you can see in the next figure that is in a very high place of the sea, where you can put this and you cannot put in another place. So the idea is that using technology to create something. So I'm not speaking about rock or traps. It's supposed to be about technology, but the idea is that how to use the technology. So we have technology knowledge, but we have also cultural knowledge. So what we can eat, what we cannot eat, depending by the religion, by a lot of things. And we have an ecological knowledge that if we catch and if you eat all the food, also all the female or the male, probably there is no food anymore. So it's a combination of technical, cultural, and ecological knowledge to create good things for humans. This is the best invention that I would like to recap for you, but just an idea that we start from simple things like fire, wheel, nail, optical lenses, and then we arrive to something very close to our days, like paper, printing press, electricity, and steam engine. It's clear that the cultural arrived from Middle East and the North Africa, where I go for United Nations many times, from China, compass and paper and gunpowder, and also for east part of Europe, like Germany, Poland, and at the end of the day, steam engine, Scotland. We will see also the invention at the end of this presentation of 20th century and 21st century that has a pretty different geographic concentration. So why it's important, the invention for people, for human? First, it's it is a way to control stuff. Let me say, we can use fire, and if we are able to control fire, we can cook food, and we can also stay warm, protect themselves from predator, and leading to social and cognitive development. That means control the fire, like control the technology. Agricultural revolution, it's the time when nomadic people transform to settled society, leading to population growth and complex civilization. Printing press enable mass communication and spread knowledge. That is most important, how to create a knowledge that could be spread all around, and also sparking renaissance and scientific evolution. Industrial revolution made possible the transition through mechanized product to transform economy and society globally. Digital revolution is clear. Introduction of the computer revolutionized the information access and communication, and AI transforming industry, healthcare, and everyday life. So technology in different aspects of our life. In agricultural, of course, we can improve irrigation systems, plow. We can also make GMO, genetically modified crops, and also we can transform the food production, and we can have mass production without any predator or insect or any kind that can produce less. So we can improve our production of agricultural things. Medical technology, it's the most important things, where we can develop a vaccine. We have for sure here Dana that can speak about this a lot of time, but of course medical imaging, robotic surgery can improve healthcare for sure, and also transportation. For starting from the invention like the wheel, the steam engine, and modern electrical vehicles, we can revolutionize how we move and transport goods around city, around nation, around continent. Communication technology, of course, starting from telegraph and telephone, we invented smartphone and so forth, and with the energy like steam engine, electricity, or renewable energy, we can power our world. So from literacy human making life to the sophisticated algorithm, today artificial intelligence is not just a story of machine, but a story of human ingenuity, evolution, and our eternal drive to understand and shape the world around us. The idea, of course, is started in prehistorical time. The brain evolved to handle survival, problem solving, and eventually storytelling, because we see a lot of rough and raw on the cover. This is the root of intelligence, biological, not artificial, but the inspiration was born. Around the 10,000 before Christ, humans shifted from nomadic to settled life, as we see before, farming, food storage, and also domestic and required planning, cooperation, and memory. All precursor to systematic thinking. Hierarchy and community emerged, and we started to tracking time, weather, and resources. The first data that was able to see. The rise of civilization, we discussed about writing and wheel as one of the most important invention before, and we revolutionized how we store it and share knowledge. From cuneiform tablet to alphabet, we externalized the memory, the wheel, the math. It's funny to understand that wheel was not invented for transportation at the start, but the earliest wheel were part of pottery wheels used on ceramic and to shape clay ceramic, just to create pottery, not to use for transportation. by the way, the first one, no wheel was invented for this reason in Mesopotamia, and more than 3,000 years before Christ. The first revolution is industrial revolution that we can claim as it is, and was around the 18th century. We started to see steam engine factory automation and reshape labor and productivity. Human is able to build machine and to make not physical work, because physical work may started to be made by machines. In the digital age that was born during the war, we remember Enigma also from Alan Turing that laid the foundation of modern computer science. And ENIAC was the first electronic computer for general purpose, even if before there was Enigma for decrypting German and Nazi code. But in the picture there is Colossus. Colossus was a set of computer developed by Codebreaker in between 43 and 45 to help cryptanalysts to of the Lawrence cipher. Colossus was not using chip or transistors, but used thermionic valves that vacuum tubes. Internet revolution started to go, and with the internet we did just compute, we connect. Information moved at light speed, and the search engine is able to understand everything happening in the world. In the picture there is IoT that you can connect anything in reality on the road, on the houses, and in the city, sorry, with something in the cloud, and so forth. This is the advent of AI and the early beginning. We can see that we started in roughly 1642. Then there was the imitation game and the imitation machine that they say Turing said that if you have something that answers as a human, probably could be a human, and if you cannot realize, probably this is something that has intelligence and smartness as a human. But there was a long path of history, and we see all things there. It's funny that understand the first area of AI is when IBM was at the fifth championship of US game show. Then there was chess again, and the second year evolution of AI was AlphaGo that beat professional Go player Lee Sedol in 2016. And then most university and the company use the technology. This is a comparison between human evolution and AI. AI exists. I made some. Okay, probably it's not AI, but it's thinking before, where you can see primate science foundation also in Aristotle law in Greek, and the syllogism by Socrates, and the idea of reasoning or something that is able to make syllogism. It's very old, but of course the AI coined by that conference was in 1956. Then there was Expo System that where I worked in late 90s, and that was the idea to use symbolic and rule system and specific programming language like Lisp or Prolog to implement AI. And then we will see nowadays that we have models to make this. The idea is what Raffaello painted in School of Athens, that was in Rome, where they say that the philosophy that is one of 4 branches of knowledge depicted in this picture, and the other was theology, poetry, and law discussing together. This most well-known people in 20th century, and this is the invention of 20th century. As you can see, there is a lot of things connected to technology that happened in 19th century and 20th century. You can see telephone, vaccination, cars, and plane, penicillin, rockets, all this kind of stuff. It's about technology made by electronics. And as you can see, a lot of things is made on USA. It's and also in West Europe, like France and Scotland. The only thing that I made two country there because the internet or the web has been invented in US due to, again, a reason of war, just because the Soviets sent to Laika on the moon, so they are able first to send some live species on the moon, and to make some other new innovation in the US. They invented using DOT and DARPA system, the internet, because of there was Cold War, and they tried to understand who was most power country of a nation in the world. And then in Switzerland, the CERN invented the WWW. That is the basis. In this century where we live at the moment, so you can see that all the technology, there is no computer, no technology, no chip, but all this invention use the internet, the previous invention, the connector, the connection. But of course, it's not related technology. It's related to how to improve the life of the people. This is the evolution of AI. Of course, we started to have symbolic AI, as we saw the four: logic, basic, and the expert system was one of the systems also represented at the time. There was a big shift from hard coding to training because they have some data, and then there was a lot of data, and we started to make a deep learning using model that will be trained by data, the large amount of data, and we can use neural networks to make a lot of things and specialize the model, like convolutional neural network for image classification. And we saw the born of a system like Siri, Alexa, and self-driving car. But now today we have a massive general purpose models that has been trained with a lot of data, like internet scale, all the internet data, all the books that is able to be represented as a model. And then we have model like GPT, BERT, and Claude, and also forth, that is able to comprehend the text, generate text, and translate code writing and the reasoning also. What AI can do now, it's classification and regression, and I don't want to go deep in technical, but this is the slide. You can see what AI is able to see. And with the typology of the model and the usage of that model, we can see CNN, that it's more for image recognition and Bayesian task. We have a sequential time series data that we can use for. So model that we can use is RNN. And of course, the most people interact with Transformer. Transformer is able to predict the new word in a sentence, and also predict all the sentence, that it can complete the sentence, and we can also start the sentence from scratch. It depends by how the transformer has been programmed. Of course, we have a GPT, BERT, T5, BART, Claude, and Gemini, that they are all model, and ChatGPT is a derivation of GPT model. We have diffusion and hybrid model. This is most well-known model, and we can see what we can do with that model in terms of encoding or decoding casual or masked language test. And that's in short the application and the impact of AI nowadays. We have company factories that produce the building block, the brick, or the hardware, let me say, chips, and the network community devices. We can also use company that produce energy, because AI has a lot of energy requirement. we can put there in data centers. Equinix and Vantage are developer of data center. We need energy. There is company that produce and manage energy. It's not the total, it's just a couple of example. And also cooling, because data center consume a lot of energy, but also it a lot, and also semiconductor that use it to create chips. And then there is apart the other, we have software infrastructure that produce module that they sell on the market, and company that use data center to produce cloud system, and also data infrastructure, because there is no anymore data warehouse. The new term is data lake, but there is a lot of data coming from a lot of sources that need to be merged to create enterprise application or app application or vertical application. I don't know if it is readable, but let me see. I zoom just a one if I'm able to. I don't think I am able to. Yes, there is a lot of challenge. There is social, technical, environmental, economic challenge, and political, scientific challenge and opportunity. But the idea is that AI could revolutionize education, science, and creativity, but also create a lot of deepen inequality and bias. So we must ask each other, who control AI? How do we align it with human values? And the journey from the caveman to AI is not over, but it is just in its beginning. Let me see if I can go back to see. Again, if we see the history as the first thing that has been invented, as we see before, before Christ, and that we have the born of Christ here, and all the technology has been invented since starting for 1400 to 2000. All this kind of invention. Before there was nothing, and this is not clear because there is something that unfortunately happened during all this journey that was war, because the most things that the human made was not only invention, innovation, but also war. This is the first of two. I finish 5 minutes. Yeah. Hello, Kiran. I know.
Yeah,
By the
Professor.
way, yeah, it's a couple of days. The slides. This is
Yeah, no problem. No problem.
okay. This is the one or two map that I would like to show. The first map is this. Okay, I have a problem with my mouse. It is in 99 how the Silicon Valley was. There was a lot of company working together with a lot. This is 101, this area, and this is the 280 interstate, and we can see a lot of company and picture that working together to produce something that could be internet, but could be also other stuff. And I work in a couple of company there from 96 to 99 to Sun Microsystem or Oracle. But the idea that they work it together to create something together again for the humanity, for the world. But what you can see now, and what the history suggests, that there is in 3000 more of human history. Humans have been at peace only 300 years of them. In other words, war is not an anomaly, but is the norm. And this is the picture that I take yesterday from a site where we can see all the conflict that is running today. But if, as you can see from the picture from Ukraine, Gaza, Sudan, Myanmar, there is a countless places where war is disrupting life, uproot community, and fracture nation. This conflict is often fueled by toxic mix of political power struggle, historical governance, and economic inequality, and deep-rooted ethnic and religious division, were often arise not from necessity, but for failure of empathize, to compromise, to listen, and to see others as human. So my last remark is technology itself is a natural. It reflects the value of the people who design and use it. It can isolate or unite, oppress or empower, destroy or heal. The real question is, what kind of future do we want to build using AI? That's the end of my presentation. I finish. I don't think there is any question.
Congratulations, Francesco, for most interesting presentation. I really enjoyed very, very much. Wonderful. And let's hope that AI can help finish some words, and or most of them. Let's hope that
Yes,
AI will
hopefully.
help finish. I've been to Africa. I've been to Congo twice, and I tell you that country really need to have some peace. Really, they're sweet people, and I've been also to Uganda, and I met people from Rwanda. You know, right in the north, where is the problem now between Uganda, Rwanda, and Congo. And oh boy, oh boy, oh boy, what I did in my effort to really, I asked an ambassador from Congo, and he gave me whatever he thinks, and all what solution he proposed, I send it to Trump. So let's see.
It's a real peacekeeper. Okay.
We pray, we pray.
War
we
stopper.
pray.
It's a war stopper. Yeah. Okay.
Any questions, everybody?
I have no question, but I just wanted to congratulate with him because it was very interesting, to see how the evolution goes from the history of humankind, because it analyzes the whole course of what intelligence is. So I really enjoyed what you did, and congratulations. Thank you very much.
Yeah, thank you, Antonio. I didn't go in deep on technology because I think that we need to speak also about which future, probably because my age, but the idea is that thinking about what's happening it's what happening next after what happening in the past. We need to learn about history to create better things for us and for the future generation.
100%, and thank you again.
I hope you can come on the 10th of October, 12th of October, here to New York. And let's organize an AI meeting on the 12th of October here in New York. Why on the 12th of October? Because I book a hallway with for a party. So we'll have a gala dinner and everything, because on the 13th is my birthday.
Okay. Happy birthday from now.
So I suggest you can come on the 12th of October. That would be a date as for our discussion before your lecture. And let's hope that AI will do some good for reinventing society and not some fake, deep fake.
Yeah.
That we know was used by
propaganda. Yeah, so it's a lot.
Deep fake. So let's hope that will be used just for very, very good and peace. Thank you so much, Francesco.
Thank you.
We will go now to the next speaker. We invite Michael Barian. And if you please, Kiran, have the presentation of our next speaker.
Yeah, our colleague Kavya will introduce him.
Our next speaker is Mr. Michael Burian. Mr. Michael has 25 years of experience in IT, 15 years in cloud, 5 years in data and AI, and 2 years in generative AI. Michael is a founder and CEO of NDI and has been Generative AI Startups founder before. He is a senior managing director in Essential and senior partner in Deloitte. Michael holds a joint master degree in mechanical engineering and business administration from Technical University of Darmstadt, Germany. Please join me in welcoming our speaker, Mr. Michael Burian.
Yes, hello. It's a pleasure to be with you. Can you hear me? And also, can you see me?
Yes,
yes, we can see here. Did you share your screen?
Yes, I did. Can you see the screen?
Yes.
Everything works, yeah? So I can get started.
Yes, perfect.
Okay, no, great, great. So thank you for having me. It's a pleasure to be with you. Yeah, I thank you for introducing me as well. Maybe one or two more words from my end on this. So I actually started my journey in generative AI almost 4.5 years back when Google Lambda was launched, and I was in my Accenture responsibility. And since then, I've been completely fascinated by the opportunities that are given to enterprises. And this is when I founded, end of 23, New Digital Intelligence, a company that is solely focusing on developing and operating digital assistance, generative AI solutions for mid-sized organizations of all kinds in 8 countries. And we are approaching the 100-employee line very quickly. And my little contribution to this wonderful conference would be sharing some of the perspectives that I gained in this work with our clients. So yeah, I wanted to talk to you about some early insights that we gained, that I gained in my practical work in transforming businesses with generative AI, the outlook that we see, and the first experiences. So let me just try to move the slides here. 1 second. So first of all, as a starting point, generative AI, what is that and where is it performing and what is ahead of us? So I think it's important to note that generative AI provides a fundamental new capability. So we have been on the AI journey for the last 10, 15 years. AI was very niche. It required a lot of training, and it could only solve very, very specific use cases. And generative AI completely changes that. It is a versatile tool that allows to, that understands text, that understands pictures, that understands contents of all kinds, can communicate with users in natural language, in multiple languages. That's also a key topic that is very important for many organizations, that you have multi-language contents now automatically, and it can create new contents. It may be text, audio, image, and it can answer questions, and it can write code, right? So the performance that we reached with this technology is astonishing. I think we had a major milestones just a few weeks back when GPT 4.5 is the first machine, the first IT system that passes the so-called Turing test. So being that when you talk to GPT 4.5 and you talk to a number of humans in parallel and you're not exposed to who is who, you will not identify the human from GPT 4.5. The new reasoning models, OpenAI 01, 03, have an IQ in the standard IQ tests of 133, so they are pretty intelligent. And also now we see first agent frameworks able to really perform multi-step tasks. We have Anthropic computer use will lead the development there with OpenAI, Operator, Manus AI, the Google projects. And rather than just giving simple answers to a simple question, these tools are now performing multi-step tasks. You may have used OpenAI a deep research, which is a deep research assistant that performs a multi-step analysis and gathers information across various sources and compiles them. What is the outlook? The outlook is the continuation of exponential growth in capability. We are on an exponential growth path for sure, and the development seems to be accelerating and further accelerating. So we see standards like MCP that are greatly improving connectivity of LLMs with application and data, which is critical. I'm coming to that in a minute. We see massive increases in context window lengths with 2 million of tokens in Google that will improve, again, the data connectivity and the connection to company or enterprise data greatly. And also the capability roadmap is significant. We see Microsoft with their own large language model May. GPT-5 is this month still announced to launch. Gemini Ultra, Anthropic 3.8, 3.9, and they will provide a further significant advancements in reasoning, in memory, and in autonomy of task fulfillment. And of course, we don't know how the future looks like and what will come when, but most of the deep industry experts, they predict artificial general intelligence, AGI, to be available in the next 3 to 5 years, which is basically around the corner. And this prediction has been greatly accelerating. So I think 10 years back, we had this still 30 to 50 year projection, and now we're saying it's 3 to 5 years. Again, these predictions are, of course, predictions, but the pace at which these predictions have been actually shorter and accelerated is significant. So we are in the most fundamental transformation of our society by technology, for sure. And very concretely, if we look at the next 2 to 3 years, what we believe will happen in enterprises and in organizations is that starting on today's baseline, which is still very relatively tiny. So while between 60 and 90% of organizations are piloting and using generative AI digital assistants in some way or form, the total, let's say, headcount equivalent of digital assistants, so the penetration of AI employees in organizations is very low still. It's a single-digit percentage maximum. So yeah, we are at the very beginning, but we believe that in the next 2 to 3 years, 60 to 90% of current capacity of human work in white-collar positions will be subject to transformation with and augmentation with AI employees. And what impact will that have? So we believe it will massively change the way of working and accelerate our productivity. So we believe we will see a world where companies and organizations will greatly increase their revenue, their global reach, their customer intimacy. They will basically reinvest all this saved time and this capacity of saved time into value generation and into acceleration of growth and acceleration of output and revenue to their clients. It will also impact the way we work as humans. So by removing repetitive tasks and by providing the ability to more oversee rather than execute, we will provide more fulfilling roles and profiles. My daughter is studying law, and we were discussing this. We often discuss this topic, and I said, today a lawyer may solve 3 cases in parallel and write all the documents for those cases and charge €200 for 1 hour. When you will be in the job market in 2 to 3 years, you will have 400 cases that you will be running in parallel. Your AI assistants will write the text, and you will charge €10,000 for 1 hour. And you will oversee what your 400 AI agents are doing. and you will give the strategy what those 400 AI agents will be doing, and that will be much more fulfilling and much more, fulfilling as a in your job, because you give the direction, you see how your strategy impacts what those 400 AI lawyers will do. And last but not least, of course, cost shifts will massively occur by redeploying these saved hours that are repetitive and reinvesting them into the more conceptual work. So where are we with the use cases today? As I said, we are at the beginning, but we see already a huge traction. So today, the use cases, the AI employee use cases, this single-digit percentage of real capacity created in corporates is focused around a few areas. So it's code generation. You have all heard of that. It is support tasks in customer care, in sales, in pre-sales. It is enterprise search and retrieval, generation of contents out of enterprise contents, data extraction and transformation, analytics, meeting summarization, of course, which is also a very important, let's say, basic step for further automation. If you have the meeting notes and the meeting summarization that you can then intake, is also use cases that we are building as NDI. You can intake to then further process those inputs. Then copywriting, image generation, coaching, and we see a huge growth in learning and coaching because, of course, generative AI employees are interactive. They can train, they can answer questions, they can do quiz. And then this is an area that is most probably the strongest growth, workflow and web automation, which is agentic, where it is performing multi-step activities like research, like providing bookings, realizing orders, and these kind of things. What are the capabilities that we see are required to now in 25 very concretely set up an AI employee and implement an AI employee in the current organization and process and data? So the LLMs, they have the brain to provide maybe above 90% of the white collar activities in corporates. If it's just about the sheer understanding and the processing of information, where they are, where the gaps are, and why we are still only at a single-digit percentage of capacity provided in organizations, are those most probably those four. So we need to connect the LLM to the data in the organization. So the LLMs only know the internet-based data, the public available data. They do not know your product data. They don't know your pricing. They don't know your specific processes in the organization or the proprietary information in the organization. And to make the LLM use case work, you need to connect the LLM to the data. You need to connect the LLM to the application. If you want to build an agent that provides executive recruiting over LinkedIn, you need to connect to the LinkedIn messaging module. You need to have the LLM being able to trigger a message in LinkedIn or to receive a message in LinkedIn or in your email inbox. And that is unfortunately not trivial because although we are living in a world of APIs, many applications are still not fully integratable, and the devil is very much in the detail. So that's the second main pillar. And then LLMs still are not perfect. They require human supervision, also for legal and other, and quality assurance and safety and security measures. We cannot leave an LLM doing an autonomous job. So we need the supervision of the LLM, the human. When do I hand over and where do I hand over to the human? What are the handover points? This needs to be carefully configured and developed. And last but not least, an LLM at the starting point will not perform greatly, but only with the continuous feedback and the continuous training. So to have a well-performing agent in your organization, you need to implement a process whereby the LLM gets the feedback and learns from that feedback. This is an example of an agentic AI platform that fulfills all these functions and is a platform on which an AI can be based. This is our strategic partner, EMA, a Silicon Valley-based startup that just recently got a major funding round last year and is strongly growing in client base. And it provides all these components. So it is able to connect to applications. It is able to connect to data. It is providing the platform for human-in-the-loop configuration, and it is providing the platform for feedback and oversight in terms of training. In order to get starting with an AI employee based on ready-to-use templates and standard AI employees that EMA, that NDI provide, typically a pilot, which is a productive use AI employee, can be set up in 4 weeks, and then there's a 2 weeks of training and validation period where the organization is reviewing and then confirming the readiness for productive use, after which the hypercare phase then starts. And such a solution will grow, as I said earlier. So basically, based on the initial setup, the AI employee will provide contents, which we call drafts, and those will be always reviewed by the human employee, and refinements will be provided as feedback. And then we, our clients as an organization, analyze where there is gaps in the performance. So an answer or an output is not yet ideal compared to the human answer that would have been given. And then there are improvements designed that can span all parts of the solution. It could be that the data has not been correctly retrieved. It could be that the data is not available. It could be that the application connectivity is not performing as expected in other areas. So it's really a cycle of continuous improvement that such a solution, such an AI employee is undergoing. And from our initial experience in the market, to be successful today in 25, implementing an AI employee is dependent on basically 4 critical success factors that we identify. The first one is, and it's not surprising, most probably it has been a pattern in the industry for a while, is to reuse ready-to-use AI employees that have been successfully deployed in other organizations. So we have seen over the last 1 or 2 years a lot of experimental approaches in specific also large organizations. Many AI projects or Gen AI projects, many pilots actually even also failed for various reasons. And to reuse an AI employee that has proven its capability in another organization is for us a key critical success factors. By the way, also the business model of New Digital Intelligence, we are seeing us not as a custom development company, but as a company that brings an existing a proven solution to our clients. Data privacy, legal, regulatory can be obstacles if they are discussed and potentially are slowing down programs. So to clarify those upfront and take a very firm and clear position is critical to those programs, because otherwise typically the programs stall and stuck. To get the the support of the employees, and without the support of the organization and the employees, an AI employee can never grow and never receive the data and the feedback. So it is critical that employees are really seeing an AI employee as their friend, as their support, as the opportunity to 10x their own productivity, to 10x their own impact. And therefore, it's critical that the AI employee in the program is positioned as something that will grow the capability rather than cut the cost. For example, one of my best clients, it's an international, it's a German-based merchandising company that has now introduced the AI digital employee to grow into 25 more countries with the same or slightly increased headcount only. So the AI employee, their digital assistant, is a growth vehicle for international expansion rather than something that will remove even a single workplace. And then the last critical success factors, and this is often discussed, very controversial, is we recommend organizations to not start with a large scale foundational transformation in terms of data cleanup or data strategy or process or application transformation. We firmly believe, and we have the evidence that putting an AI employee into production can be done in the current state, because an AI employee is at the end nothing else than a human employee. It uses the same data, it uses the same applications, it uses the same processes, it uses the same data. So we don't need to start a transformation of the foundations to start entering a journey of implementing AI employees. Of course, any transformation in the IT environments of an organization may provide value, but it is independent from the journey of AI transformation that we're seeing here. So therefore, don't wait. Don't put too many boundaries on your AI employee program. Start small. Use what has been successfully deployed in other organizations, and start the scaling. Yeah, that's basically our learnings and what I had for you. So I'm happy to take also some questions or engage into a discussion if that's of value.
Thank you for most interesting lecture, Michael. And did you see the acceptance of the other employees of an AI employee?
Sorry, can you repeat your question?
Did you see a lack of acceptance of an AI employee by the other employees? I don't think they realize that is a real employee.
Yeah, no,
Like,
and this is the reason why I put these critical success factors on the slide. We have indeed seen programs in mid-sized organizations where the employees, this example is, for example, an engineering company where the AI employee was meant to provide answers to client inquiries on the product and on the maintenance and on shipment and other, let's say, pre-sales contents. And those pre-sales engineers in these companies, these were engineers. They were really afraid that with the introduction of the AI employee, they basically would lose their jobs, right? So only once we worked with the management to clarify this in all detail and position this as a program to increase the response, reduce the response times and increase the content quality, and use again the tool to enter additional markets, and so that the employees would be safe and they wouldn't be subject to cost cutting. Only then the support of the engineering team of the employees to train and to provide the data for the employee was given. So yes, we believe it's it's a risk factor, and it happens sometimes. Also, Workers' Council and others are very careful to not support a program that is potentially just a cost-cutting program. And the moment you position it as a growth program, which, by the way, we believe is much more value for the enterprise, then we get the support.
Thank you so much. And now we will present any other questions. No, thank you, Michael. Now we will present Professor Rodolfo Valaca. He is going to speak about data to smart assistants, AI agents, and new frontiers. For me, AI agent, we've been seeing all those announcements about what is AI assistant, and you know where an AI nurse or an AI assistant is really important in the middle of Africa somewhere where nobody is to assist, and then the children in an orphanage, for example, if they have an AI nurse, they can respond. They can respond
Dana,
to AI nurse. Yes.
yeah, can we introduce Professor Rodolfo?
Yes.
Professor Rodolfo Valaca is an executive consultant in AI startups and scale-ups and AI business unit. He is a management engineer and senior manager specialized in digital innovation. Previously, he is a university professor at the Polytechnic of Milan and the University of Turin. He is a author of publications for International Journals of Electronic Business, IL Sol 24 or and Uniscience Publishers. For some years, he has been dealing with generative AI. He is trained in artificial intelligence at the Kellogg Business School of Chicago and MIT Seoul School of Management of Boston. He has worked in NLP, prompt engineering, AI model training, and AI generated video. Please join me in welcoming our speaker, Professor Rodolfo.
Good morning, everybody. Thanks, Kiram and Kiya, for your kind presentation. Can you hear me?
Yes, we can hear you, Professor.
Perfect. Today, we will talk about AI agents and new frontiers with particular reference and how AI agents can be smart assistants. Are you able to see my slides? Okay.
Yes.
As we can see.
Perfect. Let's start analyzing the role of data in artificial intelligence and particularly in AI agents. As you know, the artificial intelligence is a technology that is not good or bad in itself, but the goodness depends how it is used, and the content will generate the added value of the technology. So the data will be the heart of generating value through AI. As you know, the data set can be made of different types of data, your own data as person or as a company, public data, for example, Wikipedia, or data owned by third parties like websites, social networks, newspapers, and others, or synthetic data, artificially generated data that are significant potential in medicine, legal, and other fields in which privacy it is very important. The data availability is now, let me say, reducing close to the fact that, just 1 second, okay. Can you see my slide? Okay, yeah. The data is rapidly shrinking to the data use restriction that are in website terms of use. And this restriction made the tokens jumped from the 5 to 7% in 2023 to 33% in 2024. So this has consequences for data diversity, model alignment, and scalability, as reported in the AI index report of the Stanford University. Now let's talk AI agents. As Satya Nadella say, AI agents will replace all software. We will move from software as a service to agent as a service. There is a path from LLMs to AI agents. As you know, LLM is a type of AI that has been trained on a vast amounts of data, and an LLM will learn from existing content to generate new original content. So in this case, user make a request through a prompt, the model responds, and there are no external tools and no autonomous reasoning. This has some limitation. For example, if you ask, when is my next appointment, the model will not able to respond, cause this limitation because it has a passive react nature and the lack of access to private and the user data. The second step is the AI workflow. In this case, the user make a request through a prompt, defines the step of the AI workflow, and the tools data to consult. So, for example, we can say, when I ask you for a personal event, look in my calendar before answering. So the model follows the step-by-step instructions, provide an answer. In this case, can use external tools and external data, for example, retrieval augmented generation, and the user make all the decision. The final step in which we are now arriving are AI agents, in which, for example, a user provide a goal to AI agent and say, create and publish a post on LinkedIn every day. So the model choose the tools, thinks, for example, what is the best way to collect relevant articles, and then asks, which model writes best for LinkedIn, then thinks about the next logical step and execute it autonomously and iteratively. So, for example, the model demands itself, how can I improve this post? So the AI agents continues the cycle of thinking, acting, evaluating, and improving until it reach a predefined self-imposed quality standard. And in this case, the AI agent may become the decision maker. A definition of AI agent can be an AI system designed to operate in specific environment and to achieve goals by interacting with surrounding environment, making decisions and taking actions autonomously or semi-autonomously to execute specific tasks. Has diverse range of potential application from academic research to scheduling meetings, online shopping, or holiday planning. This chart put in evidence the differences between the traditional generative AI and the agentic generative AI. In the agentic generative AI, we have a multi-step problem processing. It runs autonomously, can reason and decide. It is stateful approach, can use different tools, and has large deterministic parts. We have three main types of AI agent: the predefined AI agents, ready to use; the customized AI agents that can be created through low-code development tools or no-code tools; and custom-built AI agent, they using AI agent creation tools. So practically, AI agent what are? AI agent perform action autonomously, such as write, send emails, search, book, trips, something that can be designed to reason through complex problem, create actionable plans, execute this plan using a suite of tools. The capabilities of AI agents are advanced reasoning, memory retention, and task execution. AI agents are digital assistants that acts together with humans. In this sense, we can define them smart assistants, and they can also coordinate each other to achieve a specific results in order to be a proper multi-agent AI system. The system architecture, the main are three: the single agents in which the AI agents perform tasks independently, the multi-agents in which the AI agent collaborates with other AI agents to perform tasks, and the human agent in which the AI works alongside people to perform tasks. This chart shows how AI agents work. Practically, the AI agents receive a task, interact with the AI environment using tools such as API, access internet, interpreting code, have some memory and opportunity to react, and then produce an autonomous actions under the human control. The key components of an AI agents are agent core, that is the brain, memory model that maintain context and continuity, perception model that interprets data from the environment, planning model that analyzes problems and devises strategies to solve them, action model that execute the planned actions, decision-making model that choose the next steps, and learning model that improves performance based on outcomes. The core technology used by an AI agents are large language models, natural language processing, reinforcement learning, generative AI, and multimodal AI. The main application are in many sectors. For example, financial analysis. Moody's uses AI agents to have report automation, simulation of economic scenarios, and collaboration between human and AI. And this reduces report production times by 40%. Another field of application, it is the business automation. For example, AI has implemented AI agents to improve and personalize customer interactions and create dynamic and personalized offers. And this increased the conversion rate of advertising campaign by 25%. Other fields can be maintenance, and particularly predictive maintenance, and logistics, and particularly optimization of logistics. Jason Clinton, that is the Chief Information Security Officer of Anthropic, said that within 1 year, virtual workers powered by AI will start operating in corporate networks. And this revolution requires companies to radically rethink their cybersecurity strategy in order to avoid serious vulnerabilities. The capabilities of AI agents are advanced problem solving. They are able to plan and execute complex tasks. Self-reflection and improvement. They analyze their own output, incorporating the feedback and repeat in order to continually improve their performance. Tool utilization. They can use tools to evaluate their output. And collaborative multi-agent framework, in which one agent generates output and other agents provides constructive criticism. AI agents framework and reasoning framework are chain of thought that split complex problem in a sequence of intermediate reasoning steps, react that reason and act, generate reasoning phrases and task-specific actions, and tree of thoughts, in which the chain of thoughts approach is used as intermediate steps toward problem solving. How to design an AI agent? To design an effective AI agent, it is necessary to follow a process structured in sequential phases. First of all, the object definition has to be clear, the objective, before starting the design. Then we have to select an LLM, that is the heart of the AI agent. And this depends on the type of task we would like to do and the data that we have for training, the computational resources that we have at our disposal, and the training we intend to do on specific data sets. Then we can go to the configuration of inputs and parameters, and we have clear inputs and parameters, like, for example, the tone of responses, the rules, and other things, in order to be clear to the AI agent what we would like to do. Then the integration with our own IT and data system, for example, our CRM, databases, personal company tools, and other things. And at the end, we have to test and continuous optimization. So we have to test in simulated environments, then elaborate user feedbacks, and then use this feedback in order to have a proper continuous improvement. The macro categories of AI agents are 4. The first is simple reflexive AI agents. They react to immediate stimuli, act in a rule-based way, and have no memory. For example, the smart thermostats in our houses that sense the room temperature and act to keep it within certain range. Then the second category is the model-based AI agents, in which they decide and act guided by a model. A mail classification and response system is an example. Then we have the third category, that goal-based AI agent, that is an example, is a robot vacuum cleaner that they decide and act guided by a specific goal. Then the fourth category, utility-based AI agents like humanoid robots, in which they optimize their process, evaluating risk and benefits to satisfy individual preferences and achieve the best outcomes. The assisted AI agent is a definition that I prefer to use because as in artificial intelligence, it is better to speak about assisted artificial intelligence. Also in the AI agents, it is better to talk about assisted AI agent. Gartner predicts that by 2030, 80% of humans will use intelligent robot daily. But this exposes us to a risk. There are risks in terms of data privacy, the risk of privacy violation. We have risk in terms of decision errors. The decision can be not in line with the user expectation, and we have risk in terms of bias. Actions influenced by bias presented in the data. So it is much better to keep the user in the loop and talk about assistant AI agent. The future of AI is agentic. This say Armand Ruiz, that is Vice President of AI platform in IBM. The agentic at the moment are still in a very early experimental stage, and we will soon start collaborating with AI agents instead of humans for some specific task. The agentic RAG is a full-blown orchestration layer over retrieval augmented generation. This changes everything because exposed to autonomy, multi-step reasoning, proactive retrieval, adaptive learning, and this leads to a 40% higher accuracy. In this agentic RAG pipeline, we can see that we make a query, we make an analysis of the query in order to understand if the data have in our possession has to be retrieved, and we grade what the data we have. If it's relevant, we go to the generation. If the generation achieve something that answer to our question, we give the answer. Otherwise, we rewrite the query and we restart with the retrieval of the data. In case the query analysis use unrelated to self data, so we proceed to find the data in a web search. We grade the data found in the web search. If are they relevant, they proceed to the generation. And in case the question is answered in a good way, we give the answer. Otherwise, we restart to rewrite the query and we restart from the beginning. In case the data is available in a LLM, we ask the LLM in order to receive the answer. According to Asha Sharm, that is the corporate vice president, head of product in Prime Microsoft AI platform, with AI agents, artificial intelligence become a workforce. Just assign a task, then an AI agent, and then review it. So the evolution is towards smart colleagues. The future virtual employees will have a significantly higher level of autonomy, and we have some elements similar to the real human colleagues. Their own memory, they have a well-defined role, and even personal account and password. The solution for us humans is tracking of virtual workers' account activities, managing autonomous digital identities, and detection suspicious activities. The level of autonomy can be different. For example, MIT Technology Review divided in 3 main categories. The lowest level, there's no impact on relevant decision-making flows. For example, when a chatbot greets you on a company website, then we have some intermediate levels in which the human provides the step and the AI agent suggested the tools. And then we have the highest level in which a fully autonomous AI agent can take action without further human approval. For each step represents a removal of human control and must be subject to a risk-benefit assessment, keeping in mind that the goal is promoting human well-being and not increasing efficiency at all costs. So again, it is important to have humans in the loop. We need to keep humans in the loop while using AI agent, giving up control bit to bit, and then considering that when LLM generates error in a chatbot, the errors stay inside that conversation. When AI agents perform errors, they can share personal information on the web. They can be amplified with further sharing on social media and can create reputation damage. Historical precedent demonstrate that maintaining human oversight is critical. For example, in 1980, computer science systems falsely indicated that over 2,000 Soviet missiles were heading toward North America. But luckily, human cross-verification over different warning systems avoided to consider this catastrophic situation as a real event. And looking that, we have to now keep in mind that the control of humans is very fundamental. The development of AI agents must occur alongside the development of guaranteed human oversights. According to Hugging Face, the open source agent system, it is the best way to maintain control because they allow for greater human oversights and what system can and cannot do. According to Dario Amodei, that is the CEO and co-founder of Anthropic, by 2027 or 2027 and 2026, we will have AI systems that are broadly better than almost all humans at almost all things. We are going towards that what is called Agent 4, or running at human speed agents that are qualitatively better than humans in AI research in all strategic fields. The AI explosion will be concentrated in 2027, in which we can have superhuman programmer. They are best of human in code developing, superhuman AI researcher that are mastering all fields of knowledge, super intelligent AI researcher that are better than human in making AI research, and artificial super intelligence, they are AI system, they are better than human at every cognitive tasks. This exposes us to structural risk. Difficult to predict at to event at the moment, the unintended consequences resulting from the interaction of intelligent multi-agent system with the complexity of the human world. The main danger, according to Google DeepMind, is R2, and this possibility can real. The AI agent can create false information so convincing as to be perfectly credible. And at macro level, this means that AI agent can undermine public trust and take control of economic and political mechanisms. In this scenario, there is a risk of finding ourselves with machines in command without there having been intentional actions. This will require a deep understanding of interaction between AGI, artificial general intelligence, infrastructure, and institutions. Now we see the available AI agent on the market. AI agent probably the best first application. It is the feature of Claude introduced in 22 October 2024 by Anthropic that habilitate Claude to interact autonomously with the computer desktop environment. For example, moving the cursor, clicking buttons, and typing text. Salesforce Agentforce, it is a suite of autonomous agents that Salesforce create for carrying out a range of tasks in the enterprises. It uses pre-configured AI agent, easy to customize and deploy, using low-code and no-code tools to make lots of things can be useful in enterprise. For example, customer support, lead generation, optimization of marketing campaign, and automation of repetitive tasks. ChatGPT tasks is the first manifestation of OpenAI as an AI agent, and it is able to send notification to the user to remind them to do things or automatically execute a preset request. OpenAI operator, it is capable of carrying out tasks for user autonomously using vision capabilities, advanced reasoning, and reinforced learning. So 87% of operation performed successfully in web-based tasks. And if it's necessary to enter credential or sensitive data, operator asks for human intervention. And in case we ask to sending mails, the operator asks the user for a final confirmation. ChatGPT Deep Research is an AI agent that is useful for complex and articulated investigation integrated into the free version of ChatGPT. The advantages are time savings, in-depth analysis, organization of result, efficiency, precision, access to information that is difficult to find, advanced customization, transparency of the process. As we can see, we have two different versions. The original version that is a variant of O3 OpenAI model that has an accuracy of 51.5%, and the light version that is free version. It is a declination of O4 mini model that has a lower accuracy that is 45.6%. Perplexity has a perplexity assistant that is an AI agent that performs tasks and interact with the other apps. It is use private owned LLM and third-party LLMs and perform tasks on user behalf, writing an email, setting a reminder, booking a restaurant, for example, also in multimodal way. If I am in some way and I would like to go in Times Square and I have in my smartphone an image of Times Square, I can ask, get me a ride to go there. And for example, the assistant, the AI agent, can automatically open Uber with available rides for your position to that destination. Perplexity has also a deep research AI agent that is freemium and is designed for complex and articulated investigation in simple 3 steps: perform a web search, read the results, analyze them, and process them, and is able to complete a report in less than 3 minutes. Then we have a Copilot Think Deeper that is an AI agent that a free version of Copilot of Microsoft, able to perform complex tasks like, for example, compare the best electric cars, suggest the home renovation, of help in the choice of buying a new generator. Manus AI is the general AI agent that performs everyday tasks such as organizing a trip, comparing insurance policies, or searching for properties, and work tasks, CD evaluation, researching B2B suppliers, code writing, developing interactive website. It is launched by a Chinese startup called the Butterfly Effect, and practically it is the first fully autonomous AI capable of planning, coordinating multiple sub-agents, and use multiple LLMs, managing complex tasks without continuous user inputs with great transparency. It is able to perform on Gaia benchmark 86.5% in order to achieve real-world problem-solving skills. Google has a different set of AI agents, starting from AI agents for final user, such as Astra, that provide real-time assistance via mobile devices, Mariner, that navigates the web, and deep research that create reports on complex tasks. Has also Google AI agents for enterprise and employees, such as Agent Space that has AI agent in organization available, such as in Agent Gallery, or to be created, such as in Agent Designer. As idea generation for enterprises, that ideas for employees, deep research for enterprises that help to create reports on complex topics for employees, and Notebook LM Plus that is able to synthesize and interact with business data for employee. Practically, the Google 2.0 Flash habilitate some interaction and perform tasks autonomously, offering ability as an AI agent, as we said, in Astra for real-time assisted in the physical world through the use of the camera screen of smartphone or smart glasses, for example, and in Mariner, the ability of the AI agent that autonomously navigate the web to perform tasks. The deep research of Google is used to report on complex topics. Practically, the user provided a prompt, for example, compare the best smartphone available in 2025. The deep research generate a customizable research plan, analyzing which smartphone, which feature, and propose a research plan that has to be approved by the user. Then deep research, search on the web, creates a report that can be interacted with by the user, and at the end produce the final report that can be exported with table and graph. It is ideal for academic papers, legal research, scientific reviews, market analysis, and is available in all languages. Talking about what is created by Google for enterprises and from employees, Agent Space, it is the Google platform used by Banco BV, KPMG, Wells Fargo, and introduce AI capabilities directly into existing workflow, breaking down the data silos. The dynamic interaction between human users and AI facilitating the discovery of information inside the enterprise, and the multimodal intelligence used by the employees habilitate actions guided by the AI agents, integrating Agent Space into Chrome, that is the familiar search box. The two main tools are Agent Gallery, that is a centralized view of available AI agents across the organization, and Agent Designer, that is a no-code interface for building custom AI agents. Then we have Idea Generation, that is a ready-to-use AI agent to generate and refine innovative ideas, detailing its strengths, weaknesses, and the path through the brainstorming process. Practically, we can create autonomously developing new ideas in any domain, combining advanced AI with a competition framework to generate and rank ideas. Gemini will practically become an autonomous agent. This say the CEO of Google DeepMind, creating a real proactive assistant in user daily activities. Now we have to analyze the performance of the AI agents. There are two main indicators. The first is ReBench, that is a benchmark for evaluating complex tasks. And we have to divide three time horizon. In short time horizon, the AI system outperforms human expert. They are able to score 4 times higher than human expert, for example, in 2 hours. As the time increases, reaching 5 hours, human expert surpasses the top AI system. In longer time horizon, for example, 32 hours, human experts outperform top AI system, as we can see in this diagram of the Stanford University. The second indicator, it is the Visual Agent Bench that analyzes the proficiency in navigating both virtual and embodied environments. As we can see, the most proprietary AI models average around a 20% success rate. This means that the current AI models are far from ready to direct deployment in agentic settings, as you can see in the diagram of the Stanford University. This is an overview of the available agent. You can see lots of them. And this is an overview of AI agent and automation. We are moving from the AI agent to the model context protocol, in which the AI agent can connect to real-world tools such as Calendar, Notion, Perplexity, Slack. Practically, the model context protocol, it is an open source protocol created by Anthropic that is secure two-way communication between AI chatbot and agents and preferred data source application, and provide tools and context to the LLM and to your AI agent. Practically, a model context protocol standardizes how AI model interact with external data sources, and it is designed with data security in order to have a data access, control, and verifiable. Another protocol is the agent-to-agent protocol that enables interoperability between AI agents. It is created by Google with over other 50 companies and is complementary to the MCP protocol. A2A enables AI agent to communicate, coordinate, and exchange information securely. And practically, AI supports rapid and long-lasting tasks, even multimodal, and collaborate with other agents to build an ecosystem. Real digital colleagues capable of collaborating in real time as a proper smart assistants. The custom AI agent can be created today through Zapier, for example, without writing a line of code. Zapier is a platform that connects your favorite apps and web services, creating an automated workflow from user-entered test language. These are able to automate repetitive tasks between different applications, and Zapier plus MCP is able to perform tasks in a real world through secure and authentic connection. If you would like to try this, you can, for example, create something to add a mail reply and how to create an agent that perform this custom action. We can do in automated way through an AI chatbot. You choose your preferred one, for example, ChatGPT, without writing any line of code. Following these 4 simple steps, you can create a system that is able to answer your slides. We arrived to the last slide, in which I would like to put in evidence how is important to have a responsible use of AI agents. We can find 10 golden rules. The first one is integrate AI agents into your daily routine. It is the future. Then choose AI agent for each specific task. Third, have clear goals in mind, output in mind before using AI agents. Then write an initial prompt with context, instruction, and request. Then check and approve the AI agent plan. Then, if the first prompt is not perfectly understood by AI agent, no problem, modify the prompt and add some example. Then reiterate and refine the prompt till the moment it is perfectly clear, even to the AI agent, what would you like to do. Then receive the final report, research, action proposed by the AI agent, but consider as a good draft that needs to be reviewed by a human mind. At the end, check the output and refine the output, keeping always humans in the loop. The future of AI lies in autonomous AI agent. This said Mark Benioff, that is the CEO of Salesforce. Thank you, everybody, and consider me at disposal for any question that you may have.
Grazie, Rodolfo.
Grazie.
Molto bella la presentazione. Any questions? I want to get that. How can I get that? I want to have for my lectures, for my research, I want to have this 5th level of researcher as my employee.
Yeah.
Where can I find that?
Okay, we have an overall picture of the different available AI agent on the market. I give you an example that can be useful. I'm planning a trip to Indonesia. And generally, I start searching on the web the main option. This time, I moved in another way. I've asked Google Deep Research to make a plan for me, and I customize the plan, and then I ask Google Deep Research to perform the best plan according my needs. And in few minutes, I receive a complete report of what I can do in Indonesia. And I follow that plan to choose my preferred option in order to have my best trip. It is simple. It is something you can do in few minutes. You can try. The first time is not perfect. The second time will be better. At the end, after using and using, you will use as in the past you are used to ask in a travel agency or in a web specialized website. So my first suggestion is to try, use, and then at the end of the story, you will find a proper smart assistant at your side.
Google research, not ChatGPT.
They have different options. The same approach can be followed in Google Deep Research, in ChatGPT Deep Research, and practically every AI company has a proper deep research option as an AI agent. You can try the different option on the market and choose what you prefer. Someone is faster, other is deeper, some other has more accuracy. You can choose what you prefer according to your needs.
Grazie professore, piacere conoscerla.
Grazie mille, Dana.
Remember, in the 12th of October, we have a live meeting in New York.
It
So
will be my pleasure.
Good. Okay.
Thank
See
you for the
very
invitation.
soon. Thank you. And please come to the panel discussion.
Yes, we will talk in the afternoon together.
Yeah, there is one more question for you, Professor Rodolfo, from Nasrullah Khilji.
Okay, perfect. Thank you, Kiran.
Thank you, Sunny. Thank you, Professor, for the presentation. Just a quick one. What do you see the future for intelligent agent? Would they be taking over human intelligence to take over in different professions, especially where we see the taking care of customers and finding solution to the business processes? Do you see that the artificial intelligence, with especially intelligent agents, will take over human expertise in future?
Thank you for your question. My personal view is that AI agent is something very new at the moment, but is something that will become very common in future. So now we can be worried about this AI agent because it's something new, but start knowing them, we can realize that can be useful, and if we manage in a proper way, cannot be dangerous. So my strong suggestion is to experiment. As my first golden rules that I show you before, the first rule is introduce AI agent in your daily routine. In this way, you can start considering as something helpful. For example, in the late 90s, when arrived the web, we were worried about the web, what can do. Now we use every day the web. So we have to start considering AI agent as something that in the future will be the common use. And to do it properly, the human intelligence, it is fundamental. So we have to keep AI agent under control thanks to the human intelligence, thanks to our mind. And human intelligence and AI agent needs to collaborate in order to perform the best outcomes we can create. But we as human, not we as AI. So for this reason, I prefer to talk as assisted AI agent. We can use this in personal life. We can use this in working. Please use 30 minutes a day to make deep research, to make agentic navigation on the web, to make other experiment with AI agent in order to perceive them something easy to control, easy to use, and useful to be at your side as smart assistants.
Thank you.
Thank you. I hope that answered your question.
Yeah, thanks for your great presentation, Professor Rodolfo.
Thank you, Kiram.
Our next speaker is Dr. Uma Mahesh. Dr. Uma Mahesh is an associate professor at ATME College of Engineering in Mysore, India. He has served as an assistant professor, guest lecturer, and lecturer for 8.5 years. He has pursued his research in Vellore Institute of Technology, popularly known as VET in Chennai, and he has qualified UGC NET exam in December 2019. He obtained his master's degree, M.Tech in VLSI Design and Embedded Systems from VTU Karnataka, India in 2012, and bachelor's degree BE in Electronics and Communication Engineering from Visvesvaraya Technological University, popularly known as VTU, Karnataka, India in 2009. He is a member of the Optical Society of America. His current research interests are in the areas of digital holography, artificial intelligence, and machine learning. Please join me in welcoming our keynote speaker, Dr. Uma Mahesh.
Thank you very much, sir. Can I share my presentation, sir?
Yes, you can, Dr. Uma.
Thank you, sir. One minute. Good afternoon, everyone, as per Indian Standard Time. Myself, Dr. Uma Mahesh RN. So today I am going to give the talk about the topic on deep convolutional neural network for binary regression of three-dimensional objects using information retrieved from digital fresnel holograms. This is one of my research articles in PhD. This has been published in Applied Physics B, Springer Journal. So this is the outline of my presentation. I will first give an idea about digital holography, deep learning, what is the 3D object I have used, and what is the hologram I have recorded, and what neural network I have used, and what are the results and conclusion. So first of all, what is holography? So first of all, whenever we consider a three-dimensional object, for example, an object which contains amplitude and phase information, when we capture the image of a three-dimensional object through a normal camera or a square law detector, we will get only intensity information. So the phase information will get lost. So if the 3D object information is O into e power I phi, O is the amplitude and phi is the phase. So when we capture the image from the camera, we will get the square of the information. So amplitude will be obtained and phase will get cancelled. So this is the major drawback of conventional imaging technique. So therefore we will go for holography. So in holography, we can capture both the intensity, that is the square of the amplitude, as well as the phase information. So in holography, what we will do, when we consider the 3D object, this object wave will be superimposed on the another plane wave, that is a reference wave. So here O into e power I phi represents the amplitude and phase information of object wave. R into e power I delta represents the amplitude and phase information of the reference wave. So what we do here is the object wave will be superimposed on the reference wave, and we capture the image in such a way that it includes both object wave information as well as reference wave information. So what happens if I do like this? Phase will not get cancelled. So in this manner, I can get both intensity as well as phase of the object wave using this superposition principle. So this is called holographic principle. So as I told you, in holography, we will use an object wave as well as a reference wave, and we will use both the waves in order to record the holographic image. So this is the actual working principle. We will consider a helium neon laser source, a coherent light source with a 0 wavelength and a 0 degree phase angle that will be passed through the beam splitter. Beam splitter will separate the beam into two parts. 50% of the light beam will get scattered through the object, and remaining 50% of the light beam gets scattered through the mirror. So this object beam and the reference beam gets interfered in order to form interference fringe pattern called hologram. If this interference fringe pattern is recorded by the photographic plate, then it is called conventional holography. Suppose if this hologram is recorded by the digital devices like charge coupled device or CMOS, complementary metal oxide semiconductor sensor, then it is called a digital hologram. So here we have used a digital holographic principle. O represents the object wave equation, R represents the reference wave equation, I represents the intensity of the recorded hologram, which contains the reference wave, object wave, as well as the square of the object wave, square of the reference wave, and the virtual image, that is the conjugate of the object wave. So in this manner, we will record the hologram, and this hologram will be passed through the numerical reconstruction algorithm. We have several algorithms like complex wave retrieval algorithm, amplitude complex wave retrieval algorithm, amplitude spectrum method, and several methods are there, convolution method. And using that algorithm, we will reconstruct the intensity image and the phase image. Next. So after applying the digital holography technique on the 3D object, we will apply deep learning. So deep learning is a branch of artificial intelligence which can be applied in several applications like classification, regression, reconstruction, segmentation, super resolution, unwrapping. In several applications, it can be applied. Next, we will use a 3D object construction, and we have constructed 18 3D objects. This is a real-time experiment where we have constructed circle, pentagon, circle, rectangle, circle, square, circle, triangle. One of the 3D objects I will tell you. For example, if I consider this XYZ coordinate, this is a three-dimensional coordinate where X coordinate represents the first plane, Y coordinate represents the second plane, and Z represents the distance or the depth between the first plane and the second plane. So if I consider a 3D object, a circle, pentagon, circle feature is present in the front plane, pentagon feature is present in the back plane. So in this manner, I will construct a 3D object, circle, pentagon. So if I do not use depth, then it is called a 2D object. Since I have used depth Z, it is called a 3D object. Next, after constructing these 3D objects, circle, pentagon, circle, rectangle, circle, triangle, circle, square, I have used digital holographic experimental setup. This is a real-time experiment where helium neon laser source has been used, which is passed through the spatial filter and further passed through the collimation lens and further passed through the beam splitter. So spatial filter will remove the unwanted interference patterns in the laser beam. Collimation beam will make the light beam parallel. This parallel light beam will be passed through the beam splitter, where 50% of the light beam is reflected through the mirror M1 and 50% of the light beam gets scattered through the 3D object. So this scattered 3D object, whatever the light beam gets reflected, it will form the object wave. So whatever the 3D objects we have constructed here, these 3D objects, pentagon, circle, rectangle, circle, square, circle, triangle, circle are used here, and we have recorded the hologram through the CMOS sensor. So we have used Fresnel propagation condition here. So this is the plane reference wave and this is the object wave. Object wave and reference wave gets interfered here, and which will be recorded through the CMOS sensor to form the hologram. We have recorded holograms at 15 distances. The wavelength of the helium neon laser source is 632 nanometer. Collimation lens focal length is 150 mm. CMOS sensor pixel pitch is 6 micron. The recorded hologram size is 1029 into 1029 because the camera size is 1600 into 1600. This is a real-time experiment which has been conducted in the lab. So after recording the hologram, we have formed the data set for 3 sets: training set, validation set, test set, where I have taken circle, triangle, circle, square, circle, pentagon, circle, rectangle in the first set and remaining 14 objects in the second set. Totally, we have taken 18 objects. Out of 18 objects, 4 objects are considered in set. Remaining 14 objects are considered in the second set. Why this is done like this? Because the problem I have considered is binary regression. Suppose if I have to perform multi-regression, then I would have considered multiple sets. Next, I have taken 75% for validation set, 15% for validation set, 75% for training set, 10% for test set. And I have formed the data set for 2268 concatenated intensity phase images. I have not used holograms. After recording hologram, this hologram is passed through the numerical reconstruction algorithm called complex wave retrieval method. And I have obtained both intensity and phase, and I have combined intensity and phase. This is the phase depth, this is the intensity. And by combining intensity and phase, this is called concatenated intensity phase image. So these are the training and validation images in the training set and validation set. Next, convolutional neural network. So after forming the data set for 2268 images, that data set is passed through the deep learning network to perform binary regression task. So convolutional neural network consists of feature extraction layer and classification layer. This classification layer is modified into regression layer to perform regression task. Only difference is in output layer, instead of doing classification, we will do regression, that is prediction between the two sets. We will consider single neuron and a linear activation function to produce the output. So the concatenated intensity phase image is of size 1029 into 3000, which will be reduced into 128 into 128 for the training purpose. I have taken 4 stages of convolutional layers and 4 stages of pooling layers. This is mainly dimensionality reduction, which will reduce the dimensionality of the feature map to produce the output. So in the first convolutional layer, I have taken 32 kernels. In the second convolutional layer, I have taken 64 kernels. In the last convolutional layer, I have taken 128 kernels. In the fourth convolutional layer, I have taken 256 kernels, where each kernel size is 3 cross 3. So I'll explain the convolutional layer working. So concatenated intensity phase image dataset is passed through this classification layer, is modified into regression layer to perform the regression task and get the result. So in the convolutional layer, I have used rectified linear unit activation function. In the classification layer, it consists of fully connected layer as well as output layer. In the fully connected layer, I have used ReLU activation function. So what is this convolutional layer? Convolutional layer basically performs 2D convolution, where I have taken 6 cross 6 input multiplied with the 3 cross 3 kernel to produce an output of 4 cross 4. So here in the 6 cross 6 input, 3 cross 3 kernel is multiplied with the 3 cross 3. This is the input and this is the kernel size. 3 cross 3 matrix will be multiplied with the 3 cross 3 kernel to produce 1 pixel map in the output. So this output will be passed through the rectified linear unit activation function, and further it will be passed through the pooling layer. So in this manner, the convolution slides. First, it will take the first part of 3 cross 3. Next, it will take the second part of 3 cross 3. Next, it will take the next part of 3 cross 3. The same process repeats till the entire matrix is completed. So in this manner, we will do convolution. I have given 6 cross 6 input. I got 4 cross 4 output because my kernel size is 3 cross 3. So my output is n minus f plus 1. N is the input, f is the kernel, 1 is the bias. Bias is used to increase the performance of the neural network. So this is how convolutional layer works. This convolution output is passed through the rectified linear unit activation function. Rectified linear unit activation function considers the values for the right side of the x-axis and discards the values for the left side of the x-axis. So here, if you see x for x greater than 0, 0 for x less than 0. So this is the equation for the rectified linear unit activation function. Next, pooling layer. Pooling layer will further reduce the dimensionality of the feature map. Max pooling will perform maximum of the pixel value and it will get the result in the output. 1, 2, 2. Maximum pixel value is 3. 3, 4, 4, 5. Maximum pixel value is 5. We can also perform average pooling and sum pooling. This I have done in the program. So like this, we will do convolution and pooling operations successively for 4 stages in order to reduce the dimensionality of the feature map. So here you can see the model summary. The concatenated intensity phase image, I have considered the size is 128 into 128. And I have taken 3 cross 3 kernel. When I explained earlier, I had taken 6 cross 6 input. 6 cross 6 will multiplied with 3 cross 3 to get 4 cross 4. So 128 will be multiplied with 3 cross 3 to produce 126 cross 126. This 126 will be reduced to 63. 63 will be reduced to 61. 61 will be reduced to 30. 30 will be reduced to 28. So in this manner, convolution and pooling operation will be performed successively for 4 stages, and we will get the result in the 4th stage as 6 cross 6 cross 256, where I have taken 256 kernels in the 4th convolutional layer. Parameters will not affect in the pooling layer, whereas in the convolutional layer, parameters will get affected because we are performing mathematical operation. 64 kernels multiplied with 3 cross 3, multiplied with 32, multiplied with the size of the kernel is 3 cross 3, plus number of bias values is 64. That will give you the number of parameters. So why do we calculate the number of parameters? Parameters will decide the complexity of the neural network. If the parameters are more, the neural network is large. If the parameters are less, the neural network is small. Like that we will find out. And in the output layer, I have taken single neuron and linear activation function to produce the output. Now in the parameter 2, I have calculated the parameters. Similarly, in the parameter 1, 32 kernels are used. The size of the kernel is 3 cross 3 multiplied with 3 because there are 3 channels in the image, plus the number of bias values in accordance with the kernels, 32. Like this, I have done the calculation to find the number of parameters. So these are the parameter calculations I have done. In the final output layer, I have taken single neuron. 2048 neurons are selected. You can select n number of neurons. It's not a rule that I have to select 2048. Among 9216, this 2D vector is converted to 1D vector. In 9216, you can select 1000 also. You can select 100 also. So this will decide the parameters. Next, after calculating the parameters, we will proceed to the results and discussion section. You can see here I have trained this convolutional neural network on the concatenated intensity phase image dataset for training and validation sets, where I have taken the loss curve on the training and validation set. I have taken loss as mean squared error. I have trained the CNN for 50 epochs. You can see here the margin between the training error and validation error is small. So the convolutional neural network is correctly converging. Similarly, I have taken the metrics as mean squared error as well as mean absolute error. The training error is also decreasing, and the margin between training mean squared error, validation mean squared error is also less. This is the graph for mean absolute error. Next, I have calculated the evaluation metrics for the convolutional neural network on both test and validation sets, where I have taken the metrics as mean absolute error. R-square score is used to measure the performance of the binary regression task. Explained variance regression score. If these two scores are approaching towards 1, then it has got good regression performance. If it is approaching 0, then it is having constant regression performance. If it is having a negative value, it means it is having a poor regression performance. So I have calculated the evaluation metrics on the test and validation sets. You can see here for the test set, I am getting 73% and 83%. For the validation set, I have got 25% and 30%. Next, I have calculated the evaluation metrics, not only on the convolutional neural network. I have compared this regression task with several machine learning regressors. In the scikit-learn, we have several machine learning models: k-nearest neighbor, support vector machine, multi-layer perceptron, decision tree, ADA boost, random forest, extra trees, gradient boosting, histogram gradient boosting, stochastic gradient descent regressors. And I have calculated the R-square score and EV regression score on both deep learning as well as machine learning regressors. You can see here 0.73 for CNN is more compared to other machine learning regressors, and 0.83 is more for CNN compared to other machine learning regressors. So I can conclude that convolutional neural network is having very good binary regression performance for this concatenated intensity phase image data set compared to other regressors. So this is my work. Thank you for providing me to present my research work.
Congratulations to most interesting presentation.
Thank you very much, madam.
I would like really to ask myself as a doctor, how can I use this deep learning?
Madam, deep learning, even I am from electronics branch, we can learn Python programming, madam. So through Python, we can learn neural networks. So we have to implement neural networks in TensorFlow. I have used a software called Google Collaboratory. So through Google Drive, Google Collaboratory, we can establish or construct a neural network, and we can modify the model, and we can generate the results.
And if I'm not, anybody can use Python and Google collaborating?
Anybody can use Python and Google Colab. I'm from electronics background. I didn't had any idea about Python. Python is a very basic, simple programming language. Even a very intermediate person can understand.
Wonderful. Any other questions? Please,
I have one.
Yes.
I am sorry
Yes.
for interrupting you. Yes, I have one question. I am the next speaker, so I can even start talking with one simple question, which is the following one. So it's not strictly related to your presentation, which is wonderful, really. Congrats, and it is also technical. You know, we really dig into the technicism of AI. You know, with deep learning and so on. But my question is something. There is a next step, you know, and it's going to talk about the future of AI, also with hardware which will be more powerful, such as the quantum computing. So I understand that you're a technical guy, and I appreciate it very much. And I want to ask you, how do you see the potential of deep learning when we're dealing with qubit and not with bytes? And if it really can be infinite times more powerful than the deep learning models that we have nowadays with this powerful hardware, which are not powerful as what will be the quantum computers with the qubits. Thank you very much.
Sorry, I didn't get you, sir. Actually, quantum computing is a different area.
So, yeah, sure. So I am
because
just
AI is a different area.
Yeah, sure. But
So I have a very less idea about quantum computing,
I
sir.
know, but I am asking basically like right now we have those hardwares, you know, with which we can apply also the logic that you spoke about.
Deep learning logic.
And yeah, the deep learning logic. And my question is the following: with hardware of the future, which could be like quantum computing, this deep learning logic, it will be infinite times more powerful with more hidden layers, with infinite numbers of hidden layers or not, in your personal point of view? Thank you.
No, sir, I don't know, sir. I'm really sorry.
All right. It is fine.
Sir.
Thank you.
Yeah. If I may add something, because it's good discussion, I think that quantum computing basically is to enhance the computing capability. So definitely, with introduction of the quantum computing, it will help to improve the efficiency of all these 3D objective visual inspection enhancement. However, I think the basic enhancement part is about the capability of computing. It's not just about, because here we're talking about the algorithm, the mechanism about how to recognize the 3D object instead of how fast or how effective the calculation would be. So this is Michelle.
You got my question.
Very tricky discussion. Yeah.
Thank you very much, Dr. Shan. You have got my question, which was this one, because we always will apply the AI logic also to a computational power of a certain hardware, which can be also a quantum computing. And I thank you for your answer.
Doctor, I did visit India and Cochin. Is that